Rangers. This video is going to be over key features of quadratic functions. This should be a review for us. So first off, we're going to start with the top. Eric is researching quadratic functions and creates a table of examples and non-examples shown. Based on his table, predict what makes something a quadratic function. So we have these examples right here. So our examples and then our non-examples. So notice the examples that are quadratic functions, the highest exponent they have is an exponent of 2 or a degree of 2. Whereas the non-examples have either a degree that's higher, like 3, or something that is lower, like 1. So quadratic functions have a degree of 2. So a function of degree 2 is a quadratic function. The standard form of a quadratic function is f of x equals ax squared plus bx plus c. Okay, where a, b, and c are real numbers and a cannot be 0, because if a is 0, then that gets rid of our x squared term and it's no longer a quadratic function. Eventually, we will be writing equations in this form, so it's important to know that we would be plugging in numbers for a, b, and c. Next, the graph of a quadratic function is called, so the shape that it is, it's that parabola or parabola, but parabola is the correct way to pronounce it. Okay, and then a really, really important part is the parent equation to the quadratic function. Remember, that is f of x equals x squared, or y equals x squared. So this, remember, is super duper important, knowing what is our quadratic function and what is not. So super duper important there. So now our vertex. So our vertex has a couple different names. It can be known as the maximum, or the minimum. Okay, point of the parabola. So it's either the highest or lowest point. So if I say what is the maximum, I'm asking what is the vertex. If I say what is the minimum, I'm asking what is the vertex as well. Okay, now the maximum and minimum have a value, okay, and that is going to be the y value of the vertex. The y value of the vertex. So we need to understand that sometimes when we say maximum, we're talking about the actual point of the vertex. And sometimes when we're just talking about the maximum or minimum value, we just want that y value. Okay, the point where the parabola crosses the x-axis, that is known as a 0. And remember, we have some other words that we know represent zeros. We have x-intercepts. We have solutions. And then the next word you won't see as much in Algebra 1, but it will pop up when you go to Algebra 2, which is roots. Okay, then the y-intercept is the coordinate where the parabola crosses the y-axis. So off to the side, we have this picture right here. We're going to label these key features. So starting off here at the top, this point right here that is crossing our y-axis, this is our y-intercept. Okay, then our parabola is crossing the x-axis at 2 different spots. So this parabola has 2 zeros. Okay, and then this lowest point at the bottom, it can either be called the vertex, and since it's the lowest point, it could also be called the minimum. Okay, then we have our axis of symmetry. Okay, so this is a new term for us. Okay, this is a vertical line that passes through the vertex. So it's a vertical line that passes through the vertex of the parabola. This is not actually part of the graph, but it's important to know because each point on the parabola will have a point with the same y value and the same distance from the axis of symmetry. So you can think of these points as a mirror image. Okay, so this allows us to mirror and reflect points over to get more points because we need at least 3 points to graph a quadratic function. So looking here, this dashed line that they have, this is known as the axis of symmetry. And then this point down here, again, it is our vertex or it's our minimum. Okay, notice how the axis of symmetry was going through the vertex. So what I was talking about the mirror image, if I have a point right here, okay, notice it's 1, 2 spaces away from the axis of symmetry. That means on the other side, 2 spaces away, I have another point, which is right there. So this point right here and this point right here are mirror images of each other. So what we're going to do now is we're just going to do some practice problems to practice labeling these key features. So starting with this first one, we're going to label the vertex, the axis of symmetry. We're going to determine if it's a maximum or minimum, and then what that value is, the zeros, if it has any, and the y-intercept. So here we go. The vertex is right here. This is 3, -4. Remember, our x values go first, our y values go second. 3, -4, which means my axis of symmetry is a vertical line that cuts that parabola in half. So I have it drawn right here. So that vertical line would be x equals 3. So it is always the x value of your vertex. And you write x equals because it is a vertical line. Now, this is the lowest point on the graph, that vertex, which means it is a minimum. And that minimum value, the lowest y value on the graph, is -4. Okay, how many zeros does it have? Well, it's crossing the x-axis at 2 different spots. So it has 2 different zeros. It has 1 and 5. And then last but not least, it's y-intercept, where it's crossing the y-axis, which is on this axis right here. It's crossing right here at 5. So my y-intercept is 0, 5. Okay, looking at the next one. The vertex is right here. That looks to be at 0, 6. Its axis of symmetry, remember it's a vertical line that cuts through the vertex. So it's right there. That would be x equals 0. It's always the x value of the vertex. This has a highest point on the graph, which means it has a maximum. That maximum value, the highest number on the graph is 6. There's no number bigger than 6 on this graph. How many zeros does it have? It has 2. It looks like it's crossing at -4 and +4. The y-intercept happens to be the same point as the vertex. That is not always the case, so please don't make that assumption. So what I would like you to do is pause the video and try to do 3 and 4 on your own, and then restart the video so you can check your work. Okay, so hopefully you gave the video a pause, and now we're going to go through it. So the vertex, that is this lowest point on the graph right here. That would be -4, 0. The axis of symmetry, remember, is a vertical line that goes through our vertex. So it's right there. That would be x equals the x value of the vertex, which is -4. This has a minimum because there's a lowest point on the graph. That minimum value is going to be the y value of the vertex, which is 0. Okay, how many zeros does it have? It's only crossing or touching the x-axis at one spot, and that spot would be at -4. So its 0 is -4. The y-intercept is right here, and that is crossing at 0, 14. So if you got them all right, give yourself a pat on the back. If you missed anything, make sure you correct it and make a note on why you missed it. That way, when you look back at your notes, you're able to remember the previous mistakes you make and not make them again. Okay, number 4, vertex is this point right here, the lowest point on the graph. It looks to be at -2, -7. The axis of symmetry is a vertical line that cuts the quadratic in half, or the parabola in half. Remember, the equation is x equals the x value of your vertex, which is -2. We did say that this has a lowest point on the graph, which makes it a minimum. That minimum value is that y value of the vertex, which is -7. So notice how we use the axis of symmetry is the x value, and then the min or max value is the y value. Zeros, this is crossing the x axis at 2 different locations. So my zeros are at -5 and 1. It has a y-intercept at -4, so we write it 0, -4. Okay. Last part of our notes, the graph of f of x equals x squared minus 2x minus 8 is shown. Use the graph to mark each statement as true or false. If it's false, rewrite the statement to make it correct. So here we go. F of x has a y-intercept at 0, -8. Well, right here is 0, -8, which is where it's crossing the y-axis. So that is a true statement. So T for true. The vertex of this graph is 1, 9. Well, we do go over 1, but we go down 9, so it's not 1, 9. It is, and I just realized I spelled vertex wrong, so that T shouldn't be there. There we go. It should be, to be correct, 1, -9, because it went down. So that was a false statement. We marked it out and made it true. Okay. F of x only has 1 0 at -2. Well, it does have a 0 at -2, but it also has one at 4. So it does not have 1 0. It has 2 zeros at -2 and +4. And again, the original statement was false. Next. F of x has a maximum value at -9. Well, this is opening upwards, so it does not have a maximum value, so this is false. And that is actually, a minimum value. So we're going to change the word maximum to minimum. And then last but not least, f of x has an axis of symmetry at x equals 1. Well, it's the x value of the vertex, which is 1, so that is a true statement. So if you have any questions over any of these key features, make sure you write them down and ask your teacher. And have a great day, Rangers.